Hello students, you are welcome to Eko Learners Support for WAEC and NECO candidates. This is a mathematics class and I'm your teacher, Folari Ademola. In today's class, we'll be looking at a topic that is very important to us, and that is angle of elevation and depression.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
By the end of today's class, we'll be able to differentiate between angle of elevation and depression, interpret problem on angle of elevation and depression into diagram, and solve problems involving angle of elevation and depression. Angle of elevation. We say this is the angle between the horizontal line of sight and the line of sight to an object above the observer. This is our common experience. In your sitting room as you are seated, if your dad walks in and asks you what is the time, you look up to the direction of the wall clock. So when you look up, because the wall clock is probably placed above your head, so when you look up, your eyes make angle of elevation. Normally, you are supposed to be looking at your dad this way or looking at the wall before you this way. But the moment you change, this is your horizontal line of sight. The moment you tilt your head and look up, you have made angle of elevation. So let's take a look at it. This man is looking at flagpole. Remember, in your various schools, assembly ground, there is a pole near it. So when you are looking at the flag, you are making angle of elevation because you are looking this way. That's angle of elevation. From your line of sight, when you look up, angle of elevation. So it is used to measure the height or distance of an object above the observer's position. So the knowledge of angle of elevation will help you to measure the height at which the object you are looking that is above you, the height it is from the ground or the base that both of you are standing on to where it's located. Angle of depression. Angle of depression. So when you as an observer, you are looking, and you are looking at an object that is below you. When you look at an object below you, because normally you're supposed to be looking straight. Then when you now look below you, you are making an angle of depression from your horizontal line of sight down to the line of sight to that object. That is angle of depression. It is used to measure the depth or distance of an object below the observer's position. Take for example, if someone is talking to you from a story building, maybe you are at the ground floor, you are in front of the building, and if someone is at the entrance or at the veranda there, and the person is talking to you down there on the floor, you will be looking at the person at an angle of elevation, but the person will be looking at you at an angle of depression. So you take note of elevation and depression. Angle of elevation and depression can be expressed in our everyday situation, such as looking up at a tall building. When you look up at a tall building, elevation. Looking down from a hilltop. When you look down, depression. Looking up at a bird on a wire. So we solve problems involving angle of elevation and depression using knowledge of Pythagoras theorem and trigonometrical ratio. Those two methods, they are going to be our tools in this journey. Let's take this example. A woman standing on the ground at a point 25 meters from the base of a building. The angle of elevation to the top of the building is 43 degrees. To the nearest meter, how tall is the building? The very first thing, we have to translate this statement into a diagram. Let's say this is the ground, and this is the building. Yes. Don't mind my building, but yes, let's take this as a building. The woman is standing here. So here is 25 meters. That's the distance between the woman and the building. The woman make an angle of elevation to the top of the building, which is 43 degrees. So the woman looks upward, angle of elevation from a line of sight to this line of sight to the top of it, 43 degrees. To the nearest meter, how tall is the building? To the nearest meter, how tall is the building? So we are interested in finding the height of the building. That is what we want to find. Now go back. This has formed a triangle, which we call right angle triangle. And remember, when we are solving problems involving right angle triangle, there are two tools that we use. We use the Pythagoras theorem and trigonometric ratio. Yes, that's your SOHCAHTOA. Good. So now we have a triangle, a right angle triangle, in which we are in need of opposite and the adjacent has been given, considering this angle. Opposite is what we are looking for and the adjacent. So we need to think about the trigonometric ratio that combines opposite and adjacent. Opposite and adjacent. Think about it. SOHCAHTOA. Yes, toa. Tan. That means we are considering tan theta equals opposite over adjacent. So in mathematics, the very first thing, your formula. In WAEC, that probably earn you 1 mark or half mark, and you don't want to throw that away. Now, our angle is tan 43 degrees equals the opposite. That's our concern, the height of the building, and the adjacent, that is 25. That's 25 meters. That's our adjacent. 25 meters. So to make this easy, we can do something here. We multiply both sides by 25 so that h, the height of the building, can stand alone. Good. So multiplying both sides by 25 gives us to 25 multiplied by tan 43 equals h. Now that we've done that, then 25 will be multiplied by tan 43. Here, this is where our 4-figure table or our calculator comes in. Because it's not a special angle that we can easily remember, so we make use of our 4-figure table or calculator. So here I'll be using tan 43. My calculator will tell me that tan 43, that is 0.9325. Students at home, I want to believe that you have done that and you've cross-checked that. Good. Now we find the product of 25 and that value. Multiply by 25, that gives us 23.318, right? So is meter, don't forget your unit, meters. Therefore, the height of the building, is, now to the nearest meter, right, is approximately 23 meters. So for WAEC, when we get here, it's not out of place if we then let them know that h is approximately, let's not forget the sign of approximation, 23 meters. So we've been able to successfully answer this question. Isn't that interesting? Fantastic. So let's move on to the next question. An observer on a cliff 100 meters above the sea level sights 2 ships due east. The angle of depression of the shifts are 54 degrees and 36 degrees respectively. Find to the nearest meter the distance between the two shifts. So let's say this happens to be the cliff, an observer on the cliff. Let's take this as a cliff. The observer is here, as the observer. The height of this cliff is just 100 meters. Sight two shifts. The angle of depression to the shifts are, so looking at the two shifts, they are on the same level, probably say, on water. So the ship 1 and maybe the ship 2. So looking at the angle of depression, that's how the observer will be looking. Let's not forget the normal sight, line of sight, the horizontal line of sight of the observer should be this, right? That's the horizontal line of sight. So this makes an observer to form angle of depression. Now let's look at the interpretation. The angle of depression of the shifts are 54 degrees and 36 degrees respectively. So the one that is closer, right? So we are going to look at it. The first one is cited this first and this. Angle of depression, you pick it from here. This will give you, look at this. That's the first one, which is a smaller one there. That's a 36 degrees. While the big one here, that's the angle of depression, which is 54 degrees. Is that interesting? Now look at where we pick our angle of depression. From the horizontal line of sight to that. So if we are to do this now, the angle of depression of the shifts are this respectively. Find to the nearest meter the distance between the two shifts. We are looking at this distance. That is from this place to this place. That's what we are interested in. Now you remember the knowledge of our Z angle, alternate angles. Z angle, alternate angles. So let's clear something here. From here down to this place, from this place to this place is 54. So automatically this angle will be 54 using alternate angle. So to this one is 36. This one will also be angle 36 using the knowledge of alternate angles. Fantastic. Now from here to here forms a right angle triangle, right? For us to be able to get this, we probably consider the biggest of it all. This is a right angle triangle, right? The cliff and this. To make it easy, we may label this as A, B, C, and maybe this point, let's call that one M. Fantastic, we've been able to interpret this. So let's solve the problem one by one. Our interest is to calculate X. But let's consider this triangle ABC. From triangle ABC, we need to first get BC. When we get BC, we then get BM. We now subtract BM from BC to get MC that we need. Good. From triangle ABC, from that triangle ABC, using our trigonometrical ratio, we have the angle and the opposite side. We need the adjacent side. So to do that, opposite and adjacent, toha, so ka, toa, that's tan. So that gives us tan theta is equals to opposite divided by adjacent. And when we do that, it becomes tan 36 degrees is equals to the opposite we have here is 100 divided by the adjacent. We don't know it, so let's just call that one BC. That's the side BC. Now, to get the side BC, we flip this. The BC comes to this side. We divide 100 by tan 36. That means side BC will be equals to 100 divided by tan 36 degree, which is going to be 100 divided by, at this point, we beckon on our calculator for the tan 36 or our 4-figure table. So take that, check, tan 36. So tan 36 from my home calculator here, it gives me 0.7265. Are we together? Yes. 0.7265. 0.7265. Now what is left for us is to say the BC, that's the side BC, equals, divide this 100 divided by 0.7265. With our calculator, we have 137.64. 137.64 meters. That's our BC. So let's leave that. We've gotten BC. The next thing for us is to get BM. Remember that the distance between two of them, which is x, our x will be equals to BC, that side, minus MC. That is where we are going. So now that we've gotten BC, the next thing for us is to calculate BM. That is from triangle ABM. From triangle ABM. That's the right angle triangle. So we need adjacent. We have been given opposite. Just what we have here, the same thing, tan theta equals opposite divided by adjacent. So it becomes tan 54 degrees equals, the opposite is 100 and the adjacent is BM. That's our interest. So just as we've done here, which I believe that shouldn't be a problem for you at home there. We cross multiply, then our BM, the side BM will become 100 divided by tan 54, which is equals to 100 divided by, so I use my calculator, you use your 4-figure table at home, or if it is your calculator, that will be 1.376. When you do that, then divide it, 100 divided by 1.376. That gives us 72.67. 72.67. Let me correct this. It is not 72.67. It is 72.67. Number after decimal is pronounced individually. Meters. Let's not forget. Remember, we have said this is triangle ABM. So yes, ABM is from ABM that we've been able to get BM. So this should be ABM, pardon me, triangle ABM. And this is also supposed to be, now let's look at, see, that is BC, we subtract BM, not MC. So let's take note of that, sorry. We subtract BM from BC. Since MC is what we are looking for, which is our X, subtract BM from BC. We have gotten our BM to be 72.67. Now to get this, we then just say our X therefore equals BC, which is 137.64 minus, remember this is our BC, minus our BM, which is 72.67. So I want to believe that you are keeping the copy of this triangle before we started the calculation so that you don't get it mixed up. Now let's subtract. Using our calculator, 137.64 minus 72.67. That gives us 64.97 meters. Since the question says to the nearest meter, we can then approximate X, that is our X, which is the nearest the distance between the two ships. Remember, we've labeled that to be X, is now going to be approximated as 65. Remember, when a bigger number, that is number from 5 upward, when it follows decimal, when you approximate it, it's going to be approximated to 1. So 1, you then add it to this 45 meters. And that is the solution to this. Let's take note of this because you're approaching WAEC or NECO. Your diagram carries mark. Take note of that. Now, look at this. When we got our BC, I did not approximate from there. If I had approximated it and I'm using it in my final working, it will affect. So you take the calculated value along with you to the next step until your final answer before you approximate. Take note of that. Interesting. So with the knowledge of what you've gained in this class, if I leave you with practice questions, I believe you're not going to disappoint me. So I will leave you with these 2 questions. Let me see what you can do. So let's take this. At a point 15 meters from the base of a flagpole, the angle of elevation of the top of the flagpole is 51. What is the height of the flagpole? Let's attempt this. Remember, at a point 50 meters from the base of the flagpole, let's say this is the flagpole, our common experience. At a point, so 15 meters to this point of the base of the flagpole, 15 meters. The angle of elevation to the top of the flagpole is 51 degrees. Elevation, remember, elevation from the horizontal line of sight to the upper part where the object is placed. Elevation. So this is where your angle will be, and that is 51 degrees. What is the height? The height of this flagpole. Remember, we said this, that we use this angle of elevation to determine the height or the distance. That's the height that we are interested in, the height of the flagpole. Now this has formed something interesting. It has formed a triangle, a right angle triangle for that matter. We have the adjacent side. We are interested in finding the opposite side, considering the angle that has been given to us. Now we think about it. Which of the trigonometrical ratio combines opposite and adjacent? Remember, so, ka, toi. Okay, tan. Fantastic. So that means tan theta equals opposite over adjacent. For WAEC and NECO, do not toy with the formula. The formula first before substitution. So tan 51 degrees equals the opposite, which is the height that we are looking for, divided by the adjacent, which is 15 meters. So here now, we multiply both sides by 15. A baby mathematician will say we cross multiply. That is for primary school level. So we are multiplying both sides by the base, that is the denominator to that age. So if I multiply this by 15, it will cancel out this 15. Then I multiply this by 15. It goes by saying 15 multiplied by tan 51 equals the height. Now 15 multiplied by the tan of 51, we check that from our 4-figure table or our calculator. So do that at home so that we'll be on the same side. 51, which is 1.2348. Right. If you are using calculator at home, maybe the first 2 digits is enough for us. But I'm just using these 4 digits after the decimal for the sake of those using 4-figure table. Oh, you are saying it is not exactly the same as 4-figure table. No problem. We just have slight variation. Calculator value is quite different from 4-figure table, but they are very, very close. So no problem. That's why it's advisable. Choose the first 2 digits if you are using calculator. Now let's multiply this by 15. 18.5. That's what I have. 18.52 equals to the height of this. Oh, you're already happy. So we're on the same page. Now, that is the height of the flagpole. In what unit? In meters. Are we asked to approximate? That is not necessary, but it beautifies the work. Therefore, the height of the flagpole is 18.52 meters. If you approximate it, no problem. So, with this, I want to believe that you can look back into question number 2. If there is any error, or you have done it well, you clap for yourself. So with this, we've come to the end of today's class. If you enjoy it, for your comments, questions, and suggestions, make do with our social media handles being displayed on your TV screen. Till we come your way next week, keep learning mathematics.